Well, hello. Today's notes are an extension of yesterday's work where we had to solve systems of equations. Here's an application where we might need to solve systems of equations. Today's notes are on what's called partial fraction decomposition. And let me give you an example of what this is all about. Let's say we have a problem like 5 over x plus 3 over x plus 1. And we want to add these fractions together. Well, to do so, we need a common denominator. That common denominator can be x times x plus 1. So what I can do to get that common denominator is multiply the second fraction everything by x, first fraction everything by x plus 1. If we do that, we get, for the first fraction, 5x plus 5. For the second fraction, we get 3x. And our entire answer becomes 8x plus 5 over x times x plus 1. Okay, now that's not really the kind of problem we're going to see today. Instead, what we're going to see today is going to give us this to start, and we have to break it down into two fractions. Oops, I should go back here. Two fractions that add up to that final answer. Okay, so let's take a look at one of these and talk about how we can do this. So here's the fraction we have to start, x plus 8 over x squared plus 6x plus 8. So let's just walk through the steps. First step in any of these is to factor your denominator. So in this case, the denominator can be factored as x plus 2 times x plus 4. Well, here's what that tells us. It tells us that this fraction can be split into two parts. One of those parts is going to be something, I'm just going to put a capital A to take the place of something, over x plus 2, plus something, and I'll use capital B in this case, over x plus 4. So what we need to do is solve for A and B. We need to solve for these two somethings. Okay, here's how we do it. Now we need to think a little bit about what we did on the previous example. If we were to add these together, we would need a common denominator. Common denominator would be what we have over here, x plus 2 times x plus 4. So if we multiply this first fraction, everything on top and bottom, by x plus 4, we'll have our common denominator. If we multiply the second fraction, everything on top and bottom, by x plus 2, we'll have our common denominator. Now, if we multiply on the bottom, we know what we're going to get, so let's not even bother doing that. Let's just focus on taking care of what's on top. And in fact, when we compare what's over here on the right side of the equal sign to what's here, we know what's going to be on the bottom, x squared plus 6x plus 8. So we can disregard all of that. Let's just focus on what's on top. Here's what we get. X plus 8 we had on top of that first fraction equals, if we distribute this, we get ax plus 4a plus, distributing again, gives us bx plus 2b. Okay, think of that as kind of your first big step. We need to break it into two fractions. We need to figure out what we need to do to get a common denominator, and we get this far. Here's the second big step. Now we need to say to ourselves, okay, here's your x terms on the right, and here's your x term on the left, and I'll think of this as 1x. So ax plus bx must add to 1x, okay? Which means that a plus b must add to 1. Ax plus bx equals 1x, a plus b equals 1. Likewise, let's think about our numbers. So terms without x's, like this and this, they must add to 8, right? They're the terms without the x's. Therefore, they're numerical terms. 4a plus 2b must add to 8. Now check this out. We've got a system of equations. We're not solving for x and y like we normally will see. We're solving for a and b. Okay, I'm going to multiply that top equation by negative 2. Negative 2a plus negative 2b equals negative 2. And the bottom equation I'm just going to bring over. 4a plus 2b equals 8. The whole reason I did that is because if I add straight down, those b's will be eliminated, and I've got 2a is equal to 6, which leads to a equals 3. Okay, that's going to give me the first answer I need. The second is b. Well, if I plug that 3 back into, I'm going to plug it into this first equation. 3 plus b equals 1. Therefore, b must be equal to negative 2. Now, we have to be careful here because the directions aren't saying solve for a and b. The directions are saying find the partial fraction decomposition. So my final answer, I need to put those variables a and b into these original fractions. So I'm going to say this will break down as 3 over x plus 2 plus negative 2 over x plus 4. Or you might say minus 2 over x plus 4. Either way is good. So now this original fraction can be broken down into these two parts right here. Okay, kind of a tricky problem, but it ends up being it ends up in a place where we have to solve a system of equations. Let's look at another one. And this one's a little bit more complex to start. We've got 3x squared minus x plus 5 over x cubed minus 2x squared plus x. So again, first thing I want to try to do is factor what's on the bottom here, and I'll start by pulling an x out of the whole works. X times x squared minus 2x plus 1. And then that'll factor as x times x minus 1 times x minus 1. Now, this one's a little different because we have a repeated factor. If you ever have a repeated factor, there's just a little trick you have to do to set this up. So first I'm going to say this is going to be a over that first factor, which is x, plus b over the second factor, which is x minus 1. Now, since you already have an x minus 1 term, you have to do something a little bit differently for the third term to deal with that third factor. So I'm going to say plus c over x minus 1 squared. Okay, we have three fractions because we had three factors here, and because we had a repeated factor, we just have to say x minus 1 squared because we can't have two fractions with the same denominator. Okay, now we need to do what we did on the previous problem. We need to figure out what the common denominator would be. It's actually all of this. But the nice thing is, to get that common denominator, we know what we need to multiply. So for example, that first fraction, we need to multiply everything top and bottom by all of this x squared minus 2x plus 1. For the second fraction, we already have an x minus 1, so what we need is an x and an x minus 1. And for that third fraction, we already have both of these x minus 1s, so we need to multiply by x. Again, we can disregard the denominator because we know what it's going to be equal to. So I'm going to write the numerator 3x squared minus x plus 5 equals, now we need to distribute all this stuff. ax squared minus 2ax plus 1a plus, distributing again, bx squared minus 1bx, and then the last term is plus cx. Okay, so that's the first big step. First big step is to split that into, in this case, three fractions. Then think if we need a common denominator, what do we need to multiply, and write down all those numerators. Disregard the denominator from this point forward. Okay, now we need to say, okay, let's look at the x squared terms, the x terms, and the numerical terms. I'll underline the x squareds. Here they are. So if 3x squared equals ax squared plus bx squared, that means 3 must be equal to a plus b. Let me write that equation. A plus b equals 3. Now let's look at the x's. I'll put 2 underlines by each of these x's. So now we've got minus 1x equals minus 2ax minus bx plus cx. That means that this minus 1 equals minus 2a minus b plus c. Let me write that out. Minus 2a minus b plus c equals minus 1. Okay, last, let's look at the numerical terms. Okay, we only have the 1s, so we get a must be equal to 5. Now let's think about this. Now the original equation was much more complex than the last example, but since you have this nice simple equation at the end, solving this system is going to be much easier. We already have one of our answers, a equals 5. We can plug that into the first equation to find the second of our answers. So 5 plus b equals 3. If we subtract 5 from both sides, that gives us b equals negative 2. Now let's take both of those and plug them into this other equation. So if I plug 5 in place of a, I get negative 2 times 5, or negative 10, minus b, so it's minus negative 2, so plus 2, plus c equals negative 1. So I've got negative 8 plus c equals negative 1. Adding 8 to both sides gives me c equals 7. All right, beautiful. We're done with our work, but we still need to write our answer in the correct form. So I'm going to take a, b, and c, plug them into what we started with. So we have 5 over x plus negative 2 over x minus 1 plus 7 over x minus 1 squared. And there is our partial fraction decomposition of this original fraction. All right, why don't you try some of those on your own? Good luck with these. They're tricky, but once you get the hang of it, every problem you see will be set up and solved the same way.